Next point from the transition and inner transition element is electronic configuration of the actinoid series elements and their ionic and atomic radii. The actinoid series elements there are 15 elements. First is actinium, then thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelium, nobelium and lawrencium. Total there are 15 elements present in actinoid series. What is the electronic configuration and its oxidation state we will discuss now. First element is actinium. Its atomic number is 89. Actinium is 89 and its electronic configuration with respect to radon. Radon is 86. So radon is 86. Atomic number is for the actinium is 89. There are total 3 electrons left there. First of all, 2 electrons enter in a s orbital. 1 electron remaining there. It enter in a d orbital. The total electrons here, 3 electrons. The 2 electrons first of all enter in a s orbital. Then 1 electron enter in a d orbital. Because why not in f orbital? Because any f orbital is last orbital is when zero field or it is half field or it is full field. It is more stable. Okay, it is more stable. Okay, when it is zero field, half field or full field, then it is more stable. Okay, that's why the last electron first of all enter in a s orbital in this s subshell, then it not enter in a f orbital, it enter in a d orbital because of the stability. Okay, then thorium, it is 90, it is 86, so 4 electron left there. In s orbital 2 electron and d orbital 2 electron. F orbital is zero field. I already told you why it is zero field, because when any elements zero field or f orbital is zero field, half field or full field, it is more stable. Then it's in 4f orbital for the actinium 0 electrons and it can lose 3 electrons from the s orbital 2 and d orbital 1. That's why its oxidation state is +3 and its atomic radii is 203 and ionic radii is 126 picometer. The next element is thorium. Thorium is 90. With respect to radon, radon is 86. Total 4 electrons left there. First of all 2 electrons enter in a s orbital, then left 2 electron enter in a d orbital, and here you can also there are total 4 electrons there. So in f orbital also 0 electrons there. In f orbital also here 0 electrons. In this f orbital there 0 electrons there. Here 0 electrons there in this f orbital. Okay, 0 electron. You can see here in this pi f orbital there are 0 electrons and its atomic radii is 180. Ionic radii is not given here. Then protactinium, it is a Pa symbol. Atomic number is 91 and it also electronic configuration with respect to radon. And last there are total actually radon is 86. So 91 minus 86, there are 5 electrons left there. The 2 electron first of all enter in a lowest energy level. It is 7s2. Then only one electron enter in a d orbital. Remaining 2 electron enter in a fill up in a f orbital, because now f orbital you can fill up and attain the stability. That's why you can enter the electron not only in d orbital, but your electron enter in a 5f orbital. Then in a 5f orbital contain 2 electrons there. It can shows +3 oxidation state. It can lose 2 electrons from s orbital and 1 electron from the d orbital. That's why it can show +3 oxidation state. Its atomic radii is 162 picometer and ionic radii is 118 picometer. The next element is uranium. Uranium is 92 and with respect to radon is 86. The total there are 6 electron left there. First of all, you know that the 2 electron enter in s orbital, then in d orbital only 1 electron, because f orbital to attain the stability म्हणजे f ऑर्बिटल ॲटलिस्ट तुम्ही हाफ फिलकडे न्या किंवा फुल फिलकडे नेण्यासाठी डी मध्ये फक्त एकच इलेक्ट्रॉन फिलअप केलेला आहे. f मध्ये 3 इलेक्ट्रॉन्स आहे and its atomic radii is 153 picometer and ionic radii is 118 picometer. The next element is neptunium. Neptunium is 93 with respect to radon is 86. The total there are 7 electrons there. So last electron enter in a 2 electron in a lowest energy level. It is in a 2. Then next one is 61. Then 5f4. I already told you d मध्ये एकच इलेक्ट्रॉन का फिलअप केला जातो कारण f ऑर्बिटल ॲटलिस्ट स्टॅबिलिटी कडे जाईल, हाफ फिल कडे जाईल, म्हणून जे काही डी मध्ये एकच बाकीचे इलेक्ट्रॉन f मध्ये फिलअप केले जातात. तर इथे 5f4 इलेक्ट्रॉन्स आहे. तर +3 का दाखवतो कारण s मधनं 2 आणि d मधनं 1 असे 3 इलेक्ट्रॉन्स इट कॅन लॉस and form a +3 oxidation state. Its atomic radii is 150 picometer and its ionic radii is 116 picometer. Then next element is plutonium. Its symbol is Pu. Atomic number is 94. With respect to radon, there are total 8 electrons. Here in s orbital 2 electrons, but d orbital there is no electron. There is 0 electrons because now f orbital due to the extra stability it can attain half fill f orbital. That's why here 6 electron maximum electron fill in this orbital. That's why in d orbital 0 electron. In f orbital total actually there are 6 electron actually in this f orbital. There are 6 electron in its f orbital and its oxidation state it can lose from from the s orbital 2 electrons and from the f orbital 1 electrons. Its oxidation state is +3. Its atomic radii is 162 and ionic radii is 115 picometer. Next element is americium. Americium symbol for the americium Am. Atomic number 95. With respect to radon, it is total 9 electrons there. So 2 electron in s orbital and 7 electron here 6 electron. That means 1 electron enter in a f orbital, not d orbital, because it is now half filled, and when this element is half filled then it is stable. Okay, then it contains in a f orbital for the americium. In its f orbital there are 7 electrons in the americium and its atomic radii 173, ionic radii is 114 picometer. Then curium, Cm, radon, there are total 10 electrons left there. Among these s electron in 2 orbitals and it only 7 electrons because now it is half filled, and half filled orbital it is more stable and 1 electron left there, it entered in a d orbital. So its electronic configuration for the curium is radon 5 7 61 7s2 and f orbital contains 7 electrons. Its atomic radii is 174 picometer and ionic radii is 112 picometer. The next element is berkelium. Its symbol is Bk and atomic number is 97. And with respect to radon, there are total 11 electrons left there. In s orbital 2 electrons, in d 0, because now f will start to fulfill to attain the stability. That's why you don't fill up electron in a d orbital. That's why all electron enter in a f orbital. You can see here till it acquire 14 electron in its f orbital. Then berkelium is 97 with respect to radon. Then 5f9 60 7s2. And its for the berkelium there are total 9 electrons in its f orbital. It can show +3 oxidation state also, because from the s2 electron, from the f1 electron it can lose there. Its atomic radii is 170 and ionic radii is 110 picometer. Then californium is 98. Its symbol is Cf. With respect to radon 5f10. There are total 12 electrons. 2 electron enter in s orbital in d0 and f in 10. And its f orbital contains total, there are 10 electrons in its f orbital. When it can shows 3+ oxidation state, at that time it contains 9 electron here. This is correct one. When it can lose here from the s orbital 2 electrons and from the f orbital 1 electron, it can show in the there are f9 system. Here it can lose 2 electron from the s orbital and 1 electron from the f. It can show f8 system, like that. It can like that. Then here it can lose from the s orbital 2 electron and from the f orbital 1 electron. For the +3 oxidation state it can show f5 system, because from the s orbital it can lose 2 electron and from the f orbital 1 electron it can lose. And in the f5 system there, in f orbital contains 5 electrons there. Okay, this is all things are correct. Californium is Cf. It is atomic number is 98. Radon with respect to radon, and there are total 12 electron left there. In s orbital 2 electron, there d orbital no any electron, and in f orbital there are 10 electrons. So from the s orbital 2 electrons and the from your f orbital 1 electron. So your system is f9 and it can show +3 oxidation state. Its atomic radii is 186 and ionic radii is 109. Then Einsteinium, there are 99 es radon. There are total how many electrons left there in Einsteinium? There are 13 electrons left there. In s orbital you can fill up 2 electrons. In d orbital no any electrons, because I already told you why not fill up in d orbital, because it attain to stability. That's why 14 electrons त्याला f orbital मध्ये कंप्लीट करायचे, म्हणून सर्वच्या सर्व f मध्ये फिल अप केले जातात. s मध्ये कंपल्सरी 2 नंतरचे राहिलेले f मध्ये. तर it can lose electron from the s orbital and 1 electron from the f orbital. That's why in f orbital contains only 10 electrons. Its atomic radii is 186, ionic radii is 98. Then next element is fermium. Its symbol is Fm and atomic number is 100. With respect to radon, 5f12 60 7s2. In there are total 14 electrons there left there. So among these 2 electron in s orbital and last electron enter in a f orbital, and 6d is 0. And when 2 electron lost from s orbital and 1 electron from f orbital, so total 5f11 electron in the +3 oxidation state. Its atomic radii is 194 and ionic radii is 904. The next element is mendelium. It is 101. Md is a symbol and atomic number is 101. It contains total 15 electrons. The 2 electron in s orbital, in 60 is 0 and 5f 13 electrons there. And for the +3 oxidation state, it can lose 2 electrons from s orbital and 1 electron from the f orbital. and F12 system, its atomic radii is 194 and ionic radii is 90. Then second last element is nobelium. Nobelium is symbol, 102 is atomic number with respect to radon. There are total 16 electrons there. So S electron in 2 orbital and F orbital is a 14. It is already fulfilled. Now it is stable. That's why in D orbital no any electrons, and when it can for the +3 oxidation state, it can lose 2 electrons from S orbital and 1 electron from the F orbital. It is not possible for the nobelium because now it is very stable. So it can show 5F13 system. Its atomic radii is 197 and ionic radii is 95. The next element is lawrencium. Lawrencium is a symbol for the lawrencium is 103. With respect to radon, there are total 17 elements there. So that's why in S orbital 2 electrons and F orbital ची capacity फक्त 14 electron ची आहे आणि तो fulfill आहे. That's why 1 electron left there. It can enter in a D orbital and it's for the +3 oxidation state साठी it can lose electron from the S2 and from the D1 and it can show +3 oxidation state, and in its 5F14 there. Its atomic radii is 171 and ionic radii is 88 picometer. In next video we will discuss some comparison between transition and inner transition elements also next video.